Okay, we are going to use what I call the 4-square method because we're going to break it down into steps because it is very important that we feel good and confident in how to get like fractions because right now they're unlike. What does it mean again when I say unlike fractions? What am I talking about?
You're talking about denominators that aren't the same.
Talking about denominators that are not the same. If you are having side conversations, I need those to end in 3, 2, 1. That way your brain is focused, you are listening, and people at your table can also focus and listen. Okay, this is a new concept for some of us. It can be tricky, but it can also be really simple as long as we're paying attention. I think you guys are going to catch on very quickly, but I want to make sure that we are not talking and disrupting others around us. Okay, so adding and subtracting fractions with like denominators is pretty simple because all you have to do is keep the denominator the same and you're just adding the numerator. So you have an example where you have your numerator and your denominator. All I'm doing on this is I'm adding 2 plus 3 to get 5. 10 stays the same. It can be simplified. You find the GCF of both your numerator and denominator, and then you divide by that. So whatever the greatest common factor is, you reduce by that number. So it reduces to 1/2. Okay, but when I add or subtract unlike denominators, okay, it says use manipulatives to add together. I don't have any, so I could draw pictures, okay? So if I drew pictures, I could do 2/5. I'm just gonna draw this to illustrate for you. I would split this up into 5 equal parts. And the one below, I would also split into 5 equal parts and then split each of those in half, okay, to show tenths, because this one is here and this one is here. So how many of the 5 parts do I need to shade?
2.
I need to shade in 2 of these. And then how many of the 10 parts? 3. All right, well, my problem is my models are not split up equally. So what I'm having to do is I need to make sure that my fifths matches the same number of pieces as my tenths. So then I would go through and split each of these and have to create tenths. So now what I'm doing is I have 4 tenths plus 3 tenths, and I can see that my total is 7 tenths, okay? This is what I'm doing without drawing all the pictures, okay?
Or you could just multiply the numerator by the denominator to get 10. And then
In this one, that would work. Yes, that would work. Okay. All right. We are going to watch a video about how to add fractions when the denominators are not the same. Oops. Okay, so we watched the video, the Math Antics video, and he showed us a way that he calls easiest common denominator, the ECD. Okay, we are going to try something called the LCD, which is a lot like LCM, least common denominator. It saves you the extra time of reducing, because when you only use the easiest common denominator, you then get to the end a lot of times and you still have a lot more reducing than if you just use the least common denominator, okay? So we are going to use what I call the 4-square method. The 4-square method is this. You write the problem, then, and you're going from left to right. So you start here, your problem will go here. You find the least common denominator. You rename your fractions. So this is where I rewrite equivalent fractions using my least common denominator. And then I simplify over here. Okay, so we're going to do a couple of examples. This is not the one in your journal, so you're just going to watch. You're going to follow along with me. Okay, my problem is 2/5 plus 3 tenths. To find the least common denominator, I figure out what is the LCM of 5 and 10. My denominators are 5 and 10. My LCM is 10. So that means that my least common denominator between both is going to be 10. So I'll rewrite both of those fractions. Notice that I did to get 2/5. How do I get to 10? Okay, I know 10 is what I'm going to use as my denominator. 5 times what is 10? 2. Well, if I do, this is like equivalent fractions, guys. So whenever you were writing equivalent fractions, whatever you do to the bottom, you have to do to the top. And this is what he was showing you in that video. So 5 times 2 is 10, but I got to do the same thing to the top. So 2 times 2 is 4. So this is my new fraction. And then 3/10, because I'm using 10 as my denominator, it's actually going to stay the same. Because 10 times 1 is 10, so 3 times 1 is 3. So this fraction isn't going to change. The only one that did is this one. Now I rewrite it so it's stacked like a normal addition problem. But am I adding both parts of the fraction? No. Which part do I add? Only the numerator. So I do 4 plus 3 to get 7. Over here on the right side is where I would write my final answer, or I would simplify it. So I would take my answer that I have here, write it over here, and then simplify if necessary. This is already in simplest form, so you're done. Okay, let's look at another example. 8/12 plus 2/4. Okay, what two numbers am I finding the least common denominator for?
12 and 4.
12 and 4. Okay, so I figure out all my multiples of 12 and 4. My LCD is going to be 12. What do I do next? What's my next step?
You multiply 12. Multiply 12 by 12 and 4 by 12.
So I'm renaming my fractions. Okay, so what I'm doing is I have 8/12. I want to rename it so that I have 12 as a denominator. Do I need to do anything to this fraction? Or can it just stay the same? 12 is already the denominator, so it can just stay the same. So I'm just going to put 8/12 over here. But 4 is not the same, right? I've got to rewrite 2/4 to equal a fraction that has 12 on the bottom. So what did I do to 4 to get 12? I multiplied it by 3. Whatever I do to the bottom, I must do to the top. So 2 times 3 is 6. Now I have two different fractions that I can add together. So I'm going to add my numerators, 8 plus 6, and I get 14/12. The right side this time is going to show the simplification process. So my answer was 14/12. What's wrong with that answer?
It's improper.
It's improper. So I've got to change it to a mixed number. And remember, to change improper fraction to mixed number, you divide. How many whole times can 12 go into 14? 1. I would have 2/12 left over, but 2/12 is simplified to 1/6. You are simplifying it to lowest terms. I don't want to see 1 and 2/12. I want to see 1 and 1/6. Does that make sense? That's what you're doing in this box, is simplifying. Okay? Okay. All right. Yes.
Like the way the guy just showed us.
Okay. So we're going to practice four-square method today. That's what we're doing. So right now what we're going to do is we're going to practice identifying that least common denominator. So we have 8 and 6. What would my multiples of 8 be? 8, 16, 24, 32. What are some multiples of 6? 6, 12, 18, 24. Okay, here's my LCD. So I want to, I don't think this one's yours. Is this one yours? Yes. Oh, it is yours. Yay. Okay. So right now you should be listing out those multiples, and then you're going to list out that 24 is your LCD. And I saw some of your pencils writing, so you're with me. Okay. All right. So now I want to write two new fractions using 24 as my common denominator. So I'm going to go ahead and write 24 as my denominator over here so I can see what I'm trying to get to. What do I multiply 8 by to equal 24? 3. Okay, so that means I'm doing the same thing to the top and bottom. So what's 4 times 3 going to give me for my numerator? 12. Okay, what about the bottom fraction? 6 times what? 4 is 24. But 2 times 4 is, which is my new numerator. Now I'm going to add my two numerators together. What's 12 plus 8? 20. My denominator stays the same. So 20 24ths is almost my answer, but I need to simplify it. What could I divide 20 and 24 both by? Yes.
2.
I can divide them by 2. Is that my GCF? Or will I have to keep reducing?
4.
Okay, I could do 4. 40 is my greatest common factor between the two. It'll save me some steps. Is there anything wrong with dividing it by 2 and then just dividing by 2 again?
No.
There's nothing wrong with that. You can do that. Or you can do it all in one step by dividing by the GCF. So if I divided each of these by 4, it reduces to 5, 6, and that's my final answer. If I did it by 2, then it would be 10 12ths, but I would have to reduce it again, and I would still end up at 5 6. Okay? All right. Now we're going to, we have this problem. So turn your page to 25. We have 5/9 minus, is that right?
Yeah.
Okay, 5/9 minus 1/6. So same thing. Start with your denominators. I want to make them match. So I got to find the LCM of both. So listing out multiples, 9, 18, 27, 36. And then multiples of 6, 6, 12, 18, 24. I already have a common denominator here, which is 18. Now, 36 is a common denominator. It's not the least common denominator. If you did it the way the guy did in the video, he was doing easiest common denominator. He was multiplying these two together to get 54. Your numbers are just a whole lot bigger that you're using versus when you use the least common denominator. You're keeping your numbers as small as possible when you use the least common denominator. Okay, so I'm going to go ahead and plug in my new denominator. And I got to ask myself, how did I get from 9 to 18? What did I multiply by?
2.
So I do the same thing to the top number. 5 times 2 gives me a new numerator of 10. So 10/18 is equivalent to 5/9. And what did I multiply 6 by to get 18? 3. Do the same thing to the top. 1 times 3 is 3. Now remember, oh, I'm subtracting here, not adding. I am subtracting, so I'm going to do 10 minus 3, which is 7. And 18 is the denominator. So my final answer should be 7/18 unless it can be simplified. But can it?
No.
It cannot. So this is my final answer. Okay. We are going to do... Was this in your journal? Did I already do this one? Oh, okay. Okay, these are the same thing. All right. So we are done with our 2 examples. You're going to do a practice page as a table.